Hi everyone, in this lecture we will learn about Fermat's theorem and we will learn how to use Fermat's theorem to answer the questions related to remainder, right? So what does the Fermat's theorem say? Okay, before learning about Fermat's theorem we will have to learn about Euler number. So if I ask you that what is the Euler number of 48? Okay, if I ask you that what is the Euler number of 48, you will have to simply do the prime factorization of 48. So 2 into 24, 2 into 12, then 2 into 6, then 2 into 3, right? 2 into 24, 2 into 12, 2 into 6, 2 into 3. So if you look at the prime factorization of 48, you will only see 2 and 3. See, are you able to notice one thing? There is one prime factor 2 and there is another prime factor 3. You can't see any prime number except 2 and 3. So if we have to find the Euler number of 48, what we will do? We will simply do 48 into, then obviously 1 minus 1 by, we will write one of the prime numbers when we do the prime factorization of 48, then into 1 minus 1 by 3. So Euler number of 48 is equal to 48 into 1 minus 1 by 2 into 1 minus 1 by 3. Why we have taken 2 and 3? Simply because in the prime factorization of 48, you will see only two prime numbers. Those prime numbers are 2 and 3. If you simplify it further, you will write 48 into 1 by 2 into 2 by 3. So 2 and 2 will cancel each other. So the Euler number of 48 is 16. So the Euler number of 48 is 16. Okay. Now let us look at Euler number. What is Euler number? See, if you have to find the Euler number of n, you will have to do one thing. See, since we have to find the Euler number of n, so you will simply write n into. Then you will do the prime factorization of n. And if you see a, b and c as prime numbers in the prime factorization of n, then you will write n into 1 minus 1 by a into 1 minus 1 by b into 1 minus 1 by c. So if you look at the Euler number of 48, what did we do? We prime factorized 48 and we found that in the prime factorization of 48 there are two prime numbers. Those prime numbers are 2 and 3. So we wrote 48 into 1 minus 1 by 2 into 1 minus 1 by 3. If we simplified it, we found that the Euler number of 48 is 16. Now let us try to find the Euler number of 54. Let us try to find the Euler number of 54. So again, if you do the prime factorization, of 54, you will only see two prime numbers. Those prime numbers are 2 and 3. And we have to find the Euler number of 54. So what we will do, we will simply write 54 into, see, we have to find the Euler number of 54. So 54 into 1 minus 1 by, okay, one prime number is 2 and then again 1 minus 1 by 3. So basically 54 into, see, there are only two prime numbers, 2 and 3, right? Are you able to notice any other prime number except 2 and 3? No. So basically 54 into 1 minus 1 by 2 into 1 by 3. This is equal to 54 into 1 by 2, then obviously 2 by 3. So what is the Euler number of 54? If you solve it, if you simplify it, you will find that 2 and 2 will cancel each other. So 54 by 3 is equal to 18. So the Euler number of 54 is 18. So hopefully you have learned something about finding the Euler number. Okay, let us find few more Euler numbers such that you will never have to learn about finding the Euler number again, right? So if I ask you that what is the Euler number of 35, so if you do the prime factorization of Euler number of 35, you will see only two prime numbers. Those prime numbers are 5 and 7. So basically again you will write 35 into 1 minus 1 by 5 into 1 minus 1 by 7. If you solve it further, 35 into 4 by 5 into 6 by 7. So 5 into 7, then 7 into 7. So the Euler number of 35 is 24. See, the Euler number of 35 is 24. The Euler number of 48 is 16. Similarly, if you try to find the Euler number of 30, you will find that the Euler number of 30 is 8. Okay, you can find the Euler number of anything. Can we find the Euler number of prime numbers? Yes, we can find. Let us try to find the Euler number of 7. If you do the prime factorization of 7, you will not be able to do. You will only see 7 in the prime factorization of 7. So how will you find, how will you write the Euler number? Simple, 7 into 1 minus 1 by a, right, into 1 minus 1 by b into 1 minus 1 by c. But there is only one prime number, so 7 into 1 minus 1 by 7. And if you solve it, you will find that Euler number of 7 is 6. Right? You need to remember one thing, that Euler number of any prime number, Euler number of any prime number is just one less than that prime number. So Euler number of 7 is obviously 6. If I ask you what is the Euler number of 13, the Euler number of 13 will be equal to 12. Why? Because 13 is again a prime number. And if you do it 13 into 1 minus 1 by 13, you will find that the Euler number of 13 is 12. So okay, we have learnt about a lot finding the Euler number. So how to use the Euler number in Fermat's theorem in finding the remainders? Okay, now let us look at the question. Now let us look at the theory. Fermat's theorem says that if a to the power is Euler number of b, and if you divide a to the Euler number of b by b, you will get remainder as 1. You will get remainder as 1. Let us understand Fermat's theorem by taking a simple question. See, you have to answer what will be the remainder when 15 to the power 10 is divided by 11. 15 to the power 10 by 11. Right? You have to answer what will be the remainder. Now notice, the Euler number of 11 is 10. See, we have found that for any prime number n, the Euler number is just one less than that prime number. What does it mean? 11 is a prime number. So what will be the Euler number of 11? The Euler number of 11 is 10. Right? So now let us relate this Fermat's theorem with this question. See, you are dividing 15 to the power 10 by 11, and this 10 is an Euler number of 11. So what will be the remainder? The remainder will be 1. The remainder will be equal to 1. See, what does the Fermat's theorem say? That if you divide a to the power Euler number of b by b, you will get remainder that is equal to 1. So if I ask you, let us take another question. If I ask you that if you divide 24 to the power 11 by 10, what will be the remainder? I am asking you, what will be the remainder? See, again, sorry, this is 10 and this is 11, right? This is 10 and this is 11. You are dividing 24 to the power 10 by 11. So now 11 is a prime number, and this 10 is an Euler number of 11. What does it mean? It means that the remainder will be equal to 1. If I ask you that if you have to divide 7 to the power 10 by 11, what will be the remainder? Again, the remainder will be 1. See, we don't have to think anything about the base. If you see that the power 10 is an Euler number of 11. So the remainder will be equal to 1. So you need to remember this theorem, this Fermat's theorem, that if you divide a to the power Euler number of b by b, you will get remainder that is equal to 1, right? So if I give you a different question, if I ask you that if you divide 100 to the power 6 by 7, what will be the remainder? What will be the remainder? Again, the remainder will be equal to 1. Why the remainder is 1 again? See, this 6 is an Euler number of 7. So basically you are, again, there is this kind of case that 100 to the power Euler number of 7, that is 6, and you are dividing 100 to the power 6 by 7. So what will be the remainder? The remainder will be equal to 1, right? Now let us solve few more questions, then you will be able to relate with Fermat's theorem more. Now there is a different question. Now the question is, if I ask you that what will be the remainder if you have to divide 15 to the power 12 by 11. What will be your answer? We have to find the remainder. See, if this is 15 to the power 12, basically we have to 15 into 15 into 15, 12 times divided by 11. So can we write it as 15 to the power 10 into 15 to the power 2 by 11? Yes, we can write. Now we will divide these numbers separately. And if you divide 15 to the power 10 by 11, we have already found that remainder will be equal to 1. Why? Because this 10 is the Euler number of 11. So if you divide 15 to the power 10 by 11, you will get remainder that is equal to 1. That is equal to 1. Now we will divide 15 to the power 2 by 11. See, you can even do one thing, that 15 to the power 2 is 15 square. So basically 2 to 5 by 11. You can simply divide 2 to 5 by 11 and you can still answer the remainder. But we have learned so about finding the remainder. So why to use a lengthy process? We should use the process that we have learned. So if you have to find that, if you divide 15 to the power 2 by 11, so basically we have learned earlier that this is basically 15 into 15 by 11. So if you divide 15 by 11 separately, so 15 by 11 separately, so the remainder is 4. So 4 into 4 by 11. So again 16 by 11. So what will be the remainder? The remainder will be equal to 5. See, why did we write here 4 into 4? Because we divided these numbers 15 and 15 by 11 separately. So if you divide 15 to the power 2 by 11, what is the remainder? The remainder is equal to 5. So basically we have got that remainder is equal to 5. So basically 1 into 5 by 11. Now tell me, if you divide 5 by 11, what will be the remainder? The remainder is going to be equal to 5. So the correct answer of this question is remainder is equal to 5. So how did we solve this question? We wrote 15 to the power 12 as 15 to the power 10 into 15 to the power 2. Then we divided those both numbers separately. And we applied Fermat's theorem to find the remainder 1, that is quickly. See, you can follow the simple approach. We have learned earlier that if we have to find the remainder when 15 to the power 12 is divided by 11, you can follow that remainder of powers concept also. But since we have learned Fermat's theorem for now, why not to use that theorem to solve these questions quickly? Now the question is, what will be the remainder when 19 to the power 32 is divided by 15? Okay, we have to answer that what will be the remainder when 19 to the power 32 by 15. I have told you in yesterday's lecture that if you see this kind of questions, see, 19 is divisible by 15 and you will get remainder. If you divide 19 by 15, you will get remainder that is equal to 4. So basically this question is 4 to the power 32 by 15. 4 to the power 32 by 15. So you can solve this question by using simple concept of remainder of powers that we have learned in yesterday's lecture. But we will try to apply Fermat's theorem to solve these questions quickly. Right? So how we will apply Fermat's theorem? See, try to find the Euler number of 15. What is the Euler number of 15? If you do the prime factorization of 15, you will only see two prime numbers 3 and 5 in the Euler number of 15. So in the prime factorization of 15, so Euler number of 15 is equal to 15 into 1 minus 1 by 3 into 1 minus 1 by 5. So basically this is equal to 15 into 2 by 3 into 4 by 5. So 3 into 5, then 5 into 1. So the Euler number of 15 is 8. So the Euler number of 15 is 8. What does it mean? Now try to recall that concept of, if you divide a to the power Euler number of b by b, what will be the remainder? The remainder will be equal to 1. Okay, we will try to make 4 to the power 32 in somehow in the form of the Euler number of 15. So tell me, can we write 4 to the power 8 into 4 to the power 8 into 4 to the power 8 into 4 to the power 8? Yeah, we can write. See, if you multiply all of these numbers, you will get 4 to the power 32. right? And we have to divide this number by 15. We have to divide this number by 15. So can we divide all of these numbers separately? Yes, we can divide all of these numbers separately. So basically, we will have to divide 4 to the power 8 by 15. Now try to apply Fermat's theorem. See, 8 is the Euler number of 15. 8 is the Euler number of 15. So if you divide a to the power Euler number of b, and if you divide by b, so you are, see, this is the same case. 8 is the Euler number of 15. So if you divide a to the power Euler number of b by b, you get remainder that is equal to 1. So basically, you will get remainder that is equal to 1, right? Now if you divided 4 to the power 8 by 15, you got remainder that is equal to 1. Again, you will divide 4 to the power 8 by 15, you will get remainder that is equal to 1. Again, if you divide 4 to the power 8 by 15, you will get remainder that is equal to 1. Again, if you divide 4 to the power 8 by 15, you will get remainder that is equal to 1. So this is basically 1 by 15. So tell me, what will be the remainder if you divide 1 by 15? The answer will be 1. See, don't get confused with so many theorems. See, you can answer each question, you can answer almost each question of remainder by using the basic concept of remainder of powers. Then why we are learning these things? We are learning these things such that in few questions we can apply these theorems to answer those questions quickly. So ultimately, these theorems will help you to increase your speed to deal with these questions quickly. So what is the correct answer? The correct answer is 1. Now the question is, what will be the remainder when 21 to the power 47 is divided by 47? Now tell me, 21 to the power 47 by 47. Try to apply Fermat's theorem to deal with this question. So now try to find the Euler number of 47. If you can recall, 47 is a prime number, and I have told you that Euler number of a prime number is just 1 less than that prime number. So the Euler number is 46. Okay, what does it mean? It means that if you divide a to the power 46 by 47, see, this 46 is the Euler number of b. This 46 is the Euler number of 47. So if you see this kind of case, you get remainder that is equal to 1. You get remainder that is equal to 1, right? So basically, what does it mean? It means that if you divide 21 to the power 46 by 47, you will get remainder that is equal to 1. Why? This 46 is the Euler number of 47. That's why you will get remainder that is equal to 1. That's why you will get remainder that is equal to 1. Now try to apply that thing here. So basically, you can write 21 to the power 47 as 21 to the power 46 into 21 to the power 1 divided by 47. Now we will divide these numbers separately by 47. See, if you divide 21 to the power 46 by 47, we have already found that you will get remainder that is equal to 1. So basically, you will get remainder that is equal to 1. Now you will divide 21 to the power 1 by 47. What will be the remainder? The remainder will be equal to 21. So 1 into 21 by 47. 1 into 21 is equal to 21 by 47. Now tell me, what will be the remainder if you divide 21 by 47? The remainder will be equal to 21. So the correct answer is 21. So the correct answer is 21. Now let us solve this question. The question asks, what will be the remainder when 1001 to the power 19 is divided by 19? So basically, we have to answer what will be the remainder when you divide 1001 to the power 19 by 19. You have to answer what is the remainder. See, try to apply Fermat's theorem in this question. See, if you learn all of these theorems, or if you try all of these questions again that we have discussed in these classes, trust me, you will definitely be able to solve the questions of remainder if you get in UPSC CSAT exam, right? And obviously, UPSC CSAT does ask questions related to the concept of remainders, right? So try to find the Euler number of 19. The Euler number of 19 is equal to 18. So if you divide a to the power 19 by 18 by, if you divide a to the power 18 if you divide a to the power 18 by 19, you will get remainder that is equal to 1. Why? We have learned from the Fermat's theorem that if you divide Euler number, if you divide a to the power Euler number of b by b, you get remainder that is equal to 1. So basically if you divide 1001 to the power 18 by 19, you will get remainder that is equal to 1. Right? Why? 18 is the Euler number of 19. So can we write it in this way? 1001 to the power 18 into 1001 to the power 1 divided by 90. Now we will divide these numbers separately. If you divide 1001 to the power 18 by 19, we have already found that the remainder is equal to 1. Now we have to find now we have to divide 1001. We have to divide 1001 to the power 1 by 90, and we have to find the remainder. Can we do the simple division? Yes, let us do. So let us divide 1001 by 19. So 19 into 5 is 95. Then obviously 19 into 2 is 38. So the remainder is 30. So 1 into 13 by 19. So basically 1 into 13 by 19. What is 1 into 13? 1 into 13 is 13. So if you divide 13 by 19, what will be the remainder? Remainder will be equal to 13. So see, we have solved so many questions related to remainders. Trust me, you don't need to solve any question except those questions which we have discussed in the classroom. You should, if you really want to be good at finding remainders, if you really want to be good at solving the questions related to remainders that you are going to get in UPSC CSAT, you don't need to solve any question except those questions which we have discussed in the classroom. You are not going to get any question except these questions where you will have to apply any different thing that we haven't discussed in the classroom, right? So hopefully in this lecture all of you learned something new, and you learned that how to apply Fermat's theorem to find the remainders quickly. Right? I will suggest you that you should try these questions again, and then if you don't, then even if you are not able to solve these questions again, you should look at the solution again. Right? See you in next lecture.